Literally, good morning, guys. I'm coming at you from Friday morning, making your video for today. We're going to launch into Chapter 8, but strangely enough, we're not launching into Lesson 1. We're launching into the second half of the chapter because it is very similar what we need to do as to what we were doing in Chapter 7. So we kind of tie them together. So we're on Lessons 8-5, and we're going to be talking now about inequalities. So we spent all this time talking about equations where everything was equal. Now we're going to talk about inequalities where things aren't equal. Okay, so today's date is the 6th and 2020. So I just want to point, this has been going through my head for the last several days. I don't know why, but I want to kind of spell inequalities in a weird way, just so you have kind of an idea of what I'm talking about. So if you are correct, that means you got something right. If you are incorrect, you got something wrong. So that prefix in means not. So if you look at this definition that I just wrote, or the word I just wrote, it's basically inequalities are things that are not equal. And with inequalities, you're going to see that there's an infinite number of correct answers. But there's a beginning point. So that's, I know that seems weird. How can we start someplace but have infinite answers? Because infinity goes on forever. Doesn't matter if it's going on forever in both directions. If it's going on in one direction, it's still infinite. All right, so we're going to do a fair model. For us, it's about a third of the page, okay? So I'm going to take our word inequality and I'm going to stick it in the center. Now for me, this is just one screen. The second screen is still part of page 1. I'm just kind of writing mine a little bit larger than I have done before. So inequality, and remember how it works. We're going to break it into 4 sections. And let's see, I want to make it big, especially this one. And then it's just one big huge box. Now again, this is not your entire page. This is about a third of your page. So this is going to be the definition of what an inequality is. This is going to be symbols. We change things around a little bit. Characteristics is what we've used before. This is going to be examples. And this is going to be a non-example. Pretty much chapter 7 is a non-example, right? Because those were all equal. Okay, so definition. It's like an equation because it is a mathematical sentence. Oops, if I could spell math today, huh? A mathematical sentence. So it has something that's like an equal sign. It allows us to solve, okay? It's a mathematical sentence that states two quantities are not equal. Okay, that sounds kind of silly, but it's kind of not true. What it's telling you is we don't have a one-for-one answer. What it's telling you is that we have a lot of answers, okay? And we're going to use an inequality symbol to address that. So here's the deal. We don't just have a one-to-one correspondence, a variable equals this number only. We have this variable equals an infinite number of solutions. Math is funny sometimes, isn't it? I know you're going, no, it's confusing. Well, everything's confusing before it becomes clear, said Yoda probably at one point, but in a different voice. All right, so what are the symbols for inequalities? We have a greater than symbol. We have a less than symbol. We have a greater than or equal to symbol. Now in this one, the number that we see is a solution plus everything else beyond it. And we have a less than or equal to symbol. So that's what we're going to be using in place of an equal sign. Okay. An example would be x plus 3 is less than 5. Numerically, we did this before, comparing. 8 is less than 12. We could make it as complicated as we wanted to. X minus 5 is less than or equal to x plus 5 minus 3x plus 2. So there's some sort of inequality symbol. Now, in the case of the top one and the bottom one, we can get x on the left and the constant on the right of the inequality symbol, and then that's something that we can interpret. So a non-example, like I said, is anything that we covered in chapter 7. Any equation is going to be a non-example for an inequality, because an equation has one answer, or it could have no answers, okay? But an inequality has an infinite number of answers. Okay, so here's the weird thing. Doesn't less than mean to subtract, and greater than mean to add and switch and all that good stuff? Sorry, I had to grab some coffee. And the answer is, yeah, but when we see words that mean inequalities, it's got to have an equal word in there as well. So let's look at that. So I'm still on the first page, maybe halfway down, if that much. So I'm going to take those symbols again, and I'm just going to put them across the top. We'll do less than, greater than, less than or equal to, greater than or equal to. And I'm going to box those, and we're going to come up with phrases that you're going to hear. Probably not going to need them to be this long, that mean these inequalities. So less than is subtraction. How do I know when less than means an inequality symbol? Well, we pair an old friend with it. Is less than. So that's that kind of equal part, right? That's how it relates to chapter 7. Is less than. Is fewer than. Oh yeah, I'm going to have to erase a lot of those lines. So when I pair an is with these phrases that typically mean subtraction, now they mean inequality symbol, less than. Okay? All right, next guy. For greater than is more than. Is greater than. Okay, now those are pretty straightforward. So again, I'll show you here. 3 is less than 5. 8 is greater than 4. Now where it gets tricky is the or equal to's, because the words you hear sound like they should be with the other symbol. But you got to think logically about it, okay? So let's start. For less than or equal to, you're going to hear words like is, at most, meaning this is the biggest it can be, but it could be less, okay? I don't know why I don't get out my eyes. Is less than or equal to. Now, if you don't get that one, you're in trouble, because they're just telling you blatantly. Is less than or equal to. Again, is always present, right? And then another one is, oh yeah, this guy. Is no more than. You can have this guy, but it can't be any more than this one, okay? So an example would be 7 is no more than 10. That sounds funny, doesn't it? 7 is less than or equal to 10. So your number has to be less than or equal to 10. That's a bad example. We'll just play along and keep moving. Okay, what about greater than or equal to? Is at least. So this is the smallest it can be, but it could be bigger. Is minimally. This is the smallest it is, but it could be bigger. Is greater than or equal to. That's about as obvious as possible. Now, when we get into the I rarely see them just write this as comparing two numbers. What I see it as is word problems, okay? And believe me, this is weird. I get it. The algebra kids kind of struggle with this too because it's a mind bender. You gotta think logically about it. Okay, I'm gonna erase some of this excess lines here, and then we're gonna write something very important, so I'm going to write it in big. Let's see, what color should I do it in? I'm going to do it in blood red. How about that? Now, here's what I need you to keep in mind. These phrases, here's where I yell. Do not, I'm going to keep yelling. Change order. Now, is it possible that order will change when we have inequality? Yeah, it's certainly possible. If I have the words less than and is greater than, yeah, I could have a switcher phrase in here, but I don't think we're going to be that mean. So again, I'm going to repeat something I said before, so this should be towards the bottom of the first page. Remember, there are an infinite number of solutions with inequalities. Not just one, infinite. It means forever. Okay, let's get into some practice of what you're going to be doing. Every day, read something slightly different. So now I'm on page 2, so I'm going to go ahead and title it again. Lesson 8-5, Inequalities. And we're at 3/6/2020. Okay, so directions. Find the solution of the inequality. Find the solution of the inequality. So you did something like this when we were doing equations. They gave us an equation, and then they gave us some numbers to test, and we were looking for the number that worked out of that group. And what changes with inequalities is that it's possible to have more than one correct answer. So they want us to test 6, 7, and 8. So I'm just going to kind of set it up in a chart. Put my inequality here in the middle. That's my work area. And then I'm going to tell if it's a solution, and the answer here is either going to be yes or no. So the numbers we're going to test are 6, 7, 8. So this case, we could have more than one correct answer, it just depends. So F plus, oh sorry, let me try that again. 6, wake up here, Rosner, haven't finished all my coffee yet. 6 plus 2, and our question is that less than 9? So I get 8 is less than 9. And the answer is, yeah, that is true. So is it a solution? The answer is yes. All right, let's try another one. 7 plus 2? Is that going to be less than 9? So let's see, I get 9 is less than 9. And the answer is no, it's false. So we have no. And then we have 8 plus 2 is less than 9. So let's see, we get 10 is less than 9. Oops, nope, 10 is greater than 9. So we have another big and another no. So in this particular case, of the 3 numbers they wanted us to test, only one of them worked. All right, let's try another example. Oops, sorry, color change. No, color change. Now these have another set of directions. Is the given value a solution of the inequality? Again, we tried this too. Given value a solution of the inequality. So we'll have 2 here. So we have x plus 3 is less than 9, and they give us x equals 4. So same thing we just did. We're going to take this 4 and we're going to substitute it in for x. So we get 4 plus 3 is greater than 9. So is 7 greater than 9? And the answer is this is false. It's not going to be true. So we would write, let's see, this guy. 4 is not a solution. Think about it, there's infinite number of solutions and we get one that doesn't work. 4 is not a solution to x plus 3 is greater than 9. There's my answer. We got one last and we're done. You hear the jingle jingle? That's my doggie in her bowl trying to lick it even though it's clean because she's already licked it. But she's always looking for more. That's a beagle for you. So we're going to take the y value 6. Oops, I went too far. Let's try that again. And we're going to substitute it in for y and see what we come up with. Is 12 less than or equal to 18 minus 6? So when I do the math, I get 12 is less than or equal to, and 18 take away 6 is 12. So is that true? And the answer is, by golly gee, it is. How though? Because of the or equal to. So 12 is equal to 12. So we would say 6 is a solution to 12 is less than or equal to 18 minus y. And there we go, guys. All right, enjoy, and I'll see you Monday. Bye now.